China. IBM. COBOL. Identification division, data division, procedure. Division. Sections, paragraphs, sentences, and statements. Common business-oriented language. COBOL is an acronym which stands for Common Business-Oriented Language. Applications. COBOL is used for developing business, typically file-oriented, applications. It is not designed for writing systems programs. You would not develop an operating system or a compiler using COBOL. Irritating. COBOL is one of the oldest computer languages in use. It was developed around the end of the 1950s. As a result, it has some idiosyncrasies which programmers may find irritating. One of the design goals was to make the language as English-like as possible. COBOL uses structural concepts normally associated with English prose such as section, paragraph, sentence, and so on. As a result, COBOL programs tend to be verbose. Some implementations require the program text to adhere to certain archaic formatting restrictions. Some implementations require the program text to adhere to certain archaic formatting restrictions. Although modern COBOL has introduced many of the constructs required to write well-structured programs, it also still retains elements which, if used, make it difficult, and in some cases impossible, to write good programs. Structure of COBOL programs. P-paragraph, P-paragraph, S, ref, S sentence, S, tense, S statement, S. Divisions are used to identify the principal components of the program text. There are 4 divisions in all. Identification division, environment division, data division, procedure division. Although some of the divisions may be omitted, the sequence in which the divisions are specified is fixed and must follow the pattern shown above. The identification division is used to supply information about the program to the programmer and to the compiler. The environment division describes to the compiler the environment in which the program will run. As the name suggests, the data division is used to provide the descriptions of most of the data to be processed by the program. The procedure division contains the description of the algorithm which will manipulate the data previously described. Like other languages, COBOL provides a means for specifying sequence, selection, and iteration constructs. Note: the keyword division in a full stop is used in every case. The dot at the end is the full stop, similar to semicolon in semi-new languages. The purpose of the identification division is to provide information about the program to the programmer and to the compiler. Most of the entries in the identification division are directed at the programmer and are treated by the compiler as comments. An exception to this is the program ID clause. Every COBOL program must have a program ID. It is used to enable the compiler to identify the program. There are several other informational paragraphs in the identification division, but we will ignore them for the moment. The identification division has the following structure: identification division, program ID, prog name, author, your name. The keywords identification division represent the division header and signal the commencement of the program text. The paragraph name program ID is a keyword. It must be specified immediately after the division header. The program name can be up to 8 characters long. The data division is used to describe most of the data that a program processes. The data division is divided into 2 main sections. File section. Working storage section. The file section is used to describe most of the data that is sent to, or comes from, the computer's peripherals. The working storage section is used to describe the general variables used in the program. The data division has the following structure. Identification division. Program ID. Sequence program. Author. Michael Coughlin. Data division. Working storage section. 01 NUM1 pick 9 value zeros. 01 NUM2 pick 9 value zeros. 01 result pick 99 value zeros. Identification division. Program ID. Sequence program. Author. Michael Coughlin. Data division. Working storage section. 01 NUM1 pick 9 value zeros. 01 NUM2 pick 9 value zeros. 01 result pick 99 value zeros. U. 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 E. 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 U. 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 E. 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 WS entries. WS entries. Working, storage section. File section entries. File section. D. This is a mess. The procedure division is where all the data described in the data division is processed and produced. It is here that the programmer describes his algorithm. The procedure division is hierarchical in structure and consists of sections, paragraphs, sentences, and statements. Only the section is optional. There must be at least one paragraph, sentence, and statement in the procedure division. In the procedure division, paragraph and section names are chosen by the programmer. The names used should reflect the processing being done in the paragraph or section. The procedure division is where all the data described in the data division is processed and produced. It is here that the programmer describes his algorithm. The procedure division is hierarchical in structure and consists of sections, paragraphs, sentences, and statements. The procedure division is A section is a block of code made up of one or more paragraphs. A section begins with the section name and ends where the next section name is encountered or where the program text ends. A section name consists of a name devised by the programmer or defined by the language followed by the word section, followed by a full stop. File section. Paragraphs. Each section consists of one or more paragraphs. A paragraph is a block of code made up of one or more sentences. A paragraph begins with the paragraph name and ends with the next paragraph or section name or the end of the program text. The paragraph name consists of a name devised by the programmer or defined by the language followed by a full stop. Print final totals. Program ID. Sentences and statements. A paragraph consists of one or more sentences. A sentence consists of one or more statements and is terminated by a full stop. Move point 21 to VAT rate. Compute VAT amount equals product cost asterisk VAT rate. Display enter name with no advancing. Accept student name. Display name entered was student name. A statement consists of a COBOL verb and an operand or operands. Subtract tax from gross pay giving net pay. Read student file. At end set end of file to true. End read. A full COBOL program. Identification division. Program ID. Sample 1. Author. Michael Coughlin. Data division. Working storage section. 01 NUM1 pick 9 value zeros. 01 NUM2 pick 9 value zeros. 01 result pick 99 value zeros. Procedure division. Calculate result. Accept NUM1. Accept NUM2. Multiply NUM1 by NUM2 giving result. Display result is equals, result. Stop run. Identification division. Program ID. Sample 1. Author. Michael Coughlin. The minimum COBOL program. Identification division. Program ID. Sample 2. Procedure division. Display prompt. Display I did it. Stop run. Identification division. Program ID. Sample 2. Procedure division. Display prompt. Display I did it. Stop run. Almost all COBOL compilers treat a line of COBOL code as if it contained two distinct areas. These are known as Area A and Area B. When a COBOL compiler recognizes these two areas, all division, section, paragraph names, FD entries, and 01 level numbers must start in Area A. All other sentences must start in Area B. Area A is 4 characters wide and is followed by Area B. COBOL Basics 1. COBOL Coding Rules. Identification Division. Program ID. Program. Asterisk this is a comment. It starts. Asterisk with an asterisk in column 1. All user-defined names, such as data names, paragraph names, section names and mnemonic names, must adhere to the following rules. They must contain at least 1 character and not more than 30 characters. They must contain at least 1 alphabetic character and they must not begin or end with a hyphen. They must be constructed from the characters A to Z, the number 0 to 9 and the hyphen. E.g. total pay, gross pay. Print report headings, customer 10 rec. All data names should describe the data they contain. All paragraph and section names should describe the function of The paragraph or section. There are basically three kinds of data used in COBOL programs. 1. Variables. 2. Literals. 3. Figurative constants. Unlike other programming languages, COBOL does not support user-defined constants. A variable is a named location in memory into which a program can put data and from which it can retrieve data. A data name or identifier is the name used to identify the area of memory reserved for the variable. Variables must be described in terms of their type and size. Every variable used in a COBOL program must have a description in the data division. Zero 1 student name pick x, 6, value spaces. Move John to student name. Display my name is, student name. COBOL is not a typed language, and the distinction between some of the data types available in the language is a little blurred. For the time being we will focus on just two data types: numeric, text or string. Data type is important because it determines the operations which are valid on the type. COBOL is not as rigorous in the application of typing rules as other languages. For example, some COBOL numeric data items may, from time to time, have values which are not numeric. In typed languages, simply specifying the type of a data item provides quite a lot of information about it. The type usually determines the range of values the data item can store. For instance, a cardinal item can store values between 065, 535 and an integer between 32, 768, 32, 767. From the type of the item, the compiler can establish how much memory to set aside for storing its values. If the type is real, the number of decimal places is allowed to vary dynamically with each calculation, but the amount of the memory used to store a real number is fixed. Because COBOL is not typed, it employs a different mechanism for describing the characteristics of the data items in the program. COBOL uses what could be described as a declaration by example strategy. In effect, the programmer provides the system with an example, or template, or picture of what the data item looks like. From the picture, the system derives the information necessary to allocate it. To create the required picture, the programmer uses a set of symbols. The following symbols are used frequently in picture clauses. 9. The digit 9 is used to indicate the occurrence of a digit at the corresponding position in the picture. X, the character X, is used to indicate the occurrence of any character from the character set at the corresponding position in the picture. V, the character V, is used to indicate position of the decimal point in a numeric value. It is often referred to as the assumed decimal point character. S. The character S indicates the presence of a sign and can only appear at the beginning of a picture. Some examples. Picture 999 a 3-digit, plus IV only, integer. Picture S999 a 3-digit, plus IV/IV, integer. Picture XXXX a 4-character text item or string. Picture 99V99A and IV real in the range 0 to 99.99. Picture S9V9A and IV/IV real in the range. If you wish, you can use the abbreviation PIC. Numeric values can have a maximum of 18 digits, i.e. 9s. The limit on string values is usually system dependent. Recurring symbols can be specified using a repeat factor inside round brackets. Pic 9, 6, is equivalent to picture 999,999. Pic 9, 6, V99 is equivalent to Pic 99999V99. Picture X, 10, is equivalent to Pic XXXXXXXXXX. Pic S9, 4, V9, 4, is equivalent to Pic S9999V9999. Pic 9, 18, is equivalent to Pic 99999999999999999. In COBOL, a variable declaration consists of a line containing the following items. 1. A level number. 2. A data name or identifier. 3. A picture clause. We can give a starting value to variables by means of an extension to the picture clause called the value clause. NUM1 VAT rate student name. Data division. Working storage section. 01 NUM1 Pic 999 value zeros. 01 VAT rate Pic V99 value 0.18. 01 student name Pic X, 10, value spaces. String/alphanumeric literals are enclosed in quotes and may consist of alphanumeric characters. E.g. Michael Ryan, 123, 123.45. Numeric literals may consist of numerals, the decimal point and the plus or minus sign. Numeric literals are not enclosed in quotes. E.g. 123, 123.45, minus 256, plus 2987. COBOL provides its own special constants called figurative constants. Space or spaces equals 0 or zeros equals 0. Quote or quotes equals high value or high values equals max value. Low value or low values equals min value. All literal equals fill with literal. Zero 1 gross bay Pic 9, 5, V99 value 13.5. Move to gross bay. 0. Zeros. Student name Pic X, 10, value Mike. Move all dash to student name. Student name Pic X, 10, value Mike. Move all dash to student name. Student name. MIKE. //F6098A job, F9500 BWD01X, F6098 notify equals F6098. // misc equals 1,1. // class equals misc class equals r user equals WD01 UJ1 password equals Monday 10 June. // // *OIB Mikel, compile and link edit a COBOL program. // *OIB Mikel PROCWSPC equals 500 name equals temp name. // compile the COBOL program. // cob exec pgm equals ijectl. // parm equals zapost lib nosake rent trunk, bin, lang, ue. // steplib dddsn equals sys1.igy.sigicomp disp equals shore. // sysan dddsn equals wd01i.ds.cobol and src, end name, disp equals shore. // syslib dddsn equals wd01i.ds.copy and copy disp equals shore blk 3120. // dddsn equals mqm.scusccob disp equals shore. // syslin dddsn equals wd01i.ds.ut.obj and src, end name, disp equals shore. // outdef output pair mode equals soci 2 chars equals kn10 knje. // sysprint dd sysout equals output equals dot outdef. // sysudump dd sysout equals asterisk. // sysut1 dd space equals 800, and WSPC, round, unit equals 3390. // sysut2 dd space equals 800, and WSPC, round, unit equals 3390. F. Student details. Working storage section. 01 Student details pick X, 26. Working storage section. 01 student da. Four. 02 gender pick X. Working storage section. 01 student details. 02 student name pick X, 10. 02 student ID pick 9, 7. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender P. In COBOL, level numbers are used to decompose a structure into its constituent parts. In this hierarchical structure, the higher the level number, the lower the item is in the hierarchy. At the lowest level, the data is completely atomic. The level numbers 01 through 49 are general level numbers, but there are also special level numbers such as 66, 77, and 88. In a hierarchical data description, what is important is the relationship of the level numbers to one another, not the actual level numbers used. COBOL Basics 2. Level numbers express data hierarchy. 01 student details. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 student ID pick 9, 7. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. 01 student details. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 student ID pick 9, 7. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. 01 student details. 05 student name. 10 surname pick X, 8. 10 initials pick XX. 05 student ID pick 9, 7. 05 course code pick X, 4. 05 grant pick 9, 4. In COBOL, the term group item is used to describe a data item which has been further subdivided. A group item is declared using a level number and a data name. It cannot have a picture clause. Where a group item is the highest item in a data hierarchy, it is referred to as a record and uses the level number 01. The term elementary item is used to describe data items which are atomic. That is, not further subdivided. An elementary item declaration consists of 1. A level number, 2. A data name, 3. Picture clause. An elementary item must have a picture clause. Every group or elementary item declaration must be followed by a full stop. Picture clauses are not specified for group data items because the size a group item is the sum of the sizes of its subordinate, elementary, Items and its type is always assumed to be pick X. The type of a group items is always assumed to be pick X because group items may have several different data items and types subordinate to them. An X picture is the only one which could support such collections. In strongly typed languages like Modula 2, Pascal or Ada, the assignment operation is simple because assignment is only allowed between data items with compatible types. The simplicity of assignment in these languages is achieved at the cost of having a large number of data types. In COBOL there are basically only 3 data types: alphabetic, pick A; alphanumeric, pick X; numeric, pick 9. But this simplicity is achieved only at the cost of having a very complex assignment statement. In COBOL, assignment is achieved using the move verb. The move copies data from the source identifier or literal to one or more destination identifiers. The source and destination identifiers can be group or elementary data items. When the destination item is alphanumeric or alphabetic, pick X or A, data is copied into the destination area from left to right with space filling or truncation on the right. When data is moved into an item, the contents of the item are completely replaced. If the source data is too small to fill the destination item entirely, the remaining area is 0 or space filled. Move Ryan to surname. Move Fitzpatrick to surname. Move Ryan to surname. Move Fitzpatrick to surname. 01 surname pick X, 8. COUGHLAN. When the destination item is numeric, or edited numeric, then data is aligned along the decimal point with 0 filling or truncation as necessary. When the decimal point is not explicitly specified in either the source or destination items, the item is treated as if it had an assumed decimal point immediately after its rightmost character. Certain combinations of sending and receiving data types are not permitted, even by COBOL. From time to time it may be useful to display messages and data values on the screen. A simple display statement can be used to achieve this. A single display can be used to display several data items or literals or any combination of these. The with no advancing clause suppresses the carriage return/line feed. Upon with no advancing literal identifier literal identifier d C9 asterisk D 1 equals Monday 01 current time pick 9 8 asterisk HHMMSSSSS equals S/100 01 current date pick 9 6 asterisk YYMMDD 01 day of year pick 9 5 asterisk YYDDD 01 DAY0 FWEK pick 9 asterisk D 1 equals Monday 01 current time pick 9 8 asterisk HHMMSSSSS equals S/100 I Y U I time day of week day date format 2 accept identifier from F current year. Display today is day year day of the year. Display the time is current hour current minute. Stop run. Procedure division. Begin. Display enter student details using template below. Display NNNNNNNNSSSSSSCCCCGGGGS. Accept student details. Accept current date from date. Accept day of year from day. Accept current time from time. Display name is initials space surname. Display date is current day space current month space current year. Display today is day year day of the year. Display the time is current hour current minute. Stop run. Identification division. Program ID. Accept and display. Author Michael Coughlin. Data division. Working storage section. 01 student details. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 student ID pick 9, 7. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. 01 current date. 02 current year pick 99. 02 current month pick 99. 02 current day pick 99. 01 day of year. 02 filler pick 99. 02 year day pick 9, 3. 01 current time. 02 current hour pick 99. 02 current minute pick 99. 02 filler pick 9, 4. Identification division. Program ID. Accept and display. Author Michael Coughlin. Data division. Working storage section. 01 student details. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 student ID pick 9, 7. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. 01 current date. 02 current year pick 99. 02 current month pick 99. 02 current day pick 99. 01 day of year. 02 filler pick 99. 02. COBOL is generally used in situations where the volume of data to be processed is large. These systems are sometimes referred to as data-intensive systems. Generally, large volumes of data arise not because the data is inherently voluminous but because the same items of information have been recorded about a great many instances of the same object. We use the term field to describe an item of information we are recording about an object, e.g. student name, date of birth, course code. We use the term record to describe the collection of fields which record information about an object. E.g. a student record is a collection of fields recording information about a student. We use the term file to describe a collection of one or more occurrences, instances, of a record type, template. It is important to distinguish between the record occurrence, i.e. the values of a record, and the record type, i.e. the structure of the record. Every record in a file has a different value but the same structure. Students.dat. Data division. File section. FD student file. 01 student details. 02 stud ID pick 9, 7. 02 stud name pick X, 8. 02 date of birth pick X, 8. Data division. File section. FD student file. 01 student details. 02 stud ID pick 9, 7. 02 stud name pick X, 8. 02 date of birth pick X, 8. Occurrences. Record type. Template. Structure. Files are repositories of data that reside on backing storage, hard disk, or magnetic tape. A file may consist of hundreds of thousands or even millions of records. Suppose we want to keep information about all the TV license holders in the country. Suppose each record is about 150 characters/bytes long. If we estimate the number of licenses at 1 million, this gives us a size for the file of 150 x 1 million equals 150 megabytes. If we want to process a file of this size, we cannot do it by loading the whole file into the computer's memory at once. Files are processed by reading them into the computer's memory one record at a time. From the year 2004. In 2004, the average RAM in a PC was around 1 GB, which was considered high-end. Most computers were still running 32-bit Windows XP, and having more than 3 GB of RAM was not common until the popularity of 64-bit OSes in the late 2000s. To process a file, records are read from the file into the computer's memory one record at a time. The computer uses the programmer's description of the record, i.e., the record template, to set aside sufficient memory to store one instance of the record. Memory allocated for storing a record is usually called a record buffer. The record buffer is the only connection between the program and the records in the file. Is from the 1950s. COBOL's design is from the 1950s. Record buffer. Program. Record buffer. Declaration. If your program processes more than one file, you will have to describe a record buffer for each file. To process all the records in an input file, each record instance must be copied, read, from the file into the record buffer when required. To create an output file containing data records, each record must be placed in the record buffer and then transferred, written, to the file. To transfer a record from an input file to an output file, we will have to read the record into the input record buffer, transfer it to the output record buffer, write the data to the output file from the output record buffer. Systems. That is because the input and output files are not the same one, and usually you are not allowed to read files that are being written onto. That is called a dirty read if it is allowed and can be useful in real-time read-only systems. Value of grant 02 grant pick 9, 4. Gender 02 gender pick X. 01 student details. Student ID 02 student ID pick 9, 7. Student name. 02 student name. Surname 03 surname pick X, 8. Initials 03 initials pick XX. Date of birth 02 date of birth. Year of birth 03 YO birth pick 99. Month of birth 03 MO birth pick 99. Day of birth 03 DO birth pick 99. Course code 02 course code pick X, 4. Value of grant 02 grant pick 9, 4. Gender 02 gender pick X, S. The record type /template /buffer of every file used in a program must be described in the file section by means of an FD, file description, entry. The FD entry consists of the letters FD and an internal file name. Data division. File section. FD student file. 01 student details. 02 student ID pick 9, 7. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 date of birth. 03 YO birth pick 9, 2. 03 MO birth pick 9, 2. 03 DO birth pick 9, 2. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X, D. So FD student file full stop points towards the file that is determined elsewhere. The 01 student details is the group record name. In other languages like C, the grouped fields are called structs. // step 160 exec pgm equals buac 25 cond equals 4 lt // students ddddsn equals students.det disp equals shore / has additional tools to deal with big data. Students.dat is the file name on the disk. COBOL is a file-based database system and databases are stored inside and as files. In contrast, relational databases use links, references, and objects to join various structures together. COBOL is most suited for going through all needed data at once. That is not feasible with big data. Modern COBOL, 2023, hopefully has additional tools to deal with big data. On disk or tape, by means of the select and assign clause. Disk. Introduction to sequential files. The select and assign clause. / step 160 exec pgm equals buac 25 cond equals 4 lt / students ddddsn equals students.det disp equals shore / step 160 exec pgm equals buac 25 cond equals 4 lt / students ddddsn equals students.det disp equals shore. Environment division. Input-output section. File control. Select student file. Assign to students. Data division. File section. FD student file. 01 student details. 02 student ID pick 9, 7. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 date of birth. 03 YO birth pick 9, 2. 03 MO birth pick 9, 2. 03 Doby. Line sequential means each record is followed by the carriage return and line feed characters. Record sequential means that the file consists of a stream of bytes. Only the fact that we know the size of each record allows us to retrieve them. Record line organization is select file name assigned to external file reference. Open. Before your program can access the data in an input file or place data in an output file, you must make the file available to the program by opening it. Read. The read copies a record occurrence/instance from the file and places it in the record buffer. Write. The write copies the record it finds in the record buffer to the file. Close. You must ensure that, before terminating, your program closes all the files it has opened. Failure to do so may result in data not being written to the file or users being prevented from accessing the file. That is because writing is an excluding privilege. If other processes were allowed to change the data while you were modifying it, the results would be unpredictable and systematically useless. When you open a file, you open internal file name. Open internal file name. When you open a file, you have to indicate to the system how you want to use it, e.g. input, output, extend, so that the system can manage the file correctly. Opening a file does not transfer any data to the record buffer, it simply provides access. Once the system has opened a file and made it available to the program, It is the programmer's responsibility to process it correctly. Remember, the file record buffer is our only connection with the file end. It is only able to store a single record at a time. To process all the records in the file, we have to transfer them, 1 record at a time, from the file to the buffer. COBOL provides the read verb for this purpose. Time. The single record at a time inputting is from the age when technology was not electronically reliable and when the memory space was counted in bytes. The trick is that you only need as much memory as one database row or a record because you can offload that data onto whatever receives the output, such as another file or a screen. Keep in mind, disk space has always been more plentiful than the memory, RAM, space. So they could process megabytes of database data with just few kilobytes of RAM by only storing one record at a time. Once the system has opened a file and made it available to the program, it is the programmer's responsibility to process it correctly. Remember, the file record buffer is our only connection with the file end. It is only able to store a single record at a time. To process all the records in the file, we have to transfer them, 1. Record at a time, from the file to the buffer. COBOL provides the read verb for this purpose. End, read. At end statement block. Into identifier. Read internal file name next record. The internal file name specified must be a file that has been opened for input. The next record clause is optional and generally not used. Using into identifier clause causes the data to be read into the record buffer and then copied from there to the specified identifier in one operation. When this option is used, there will be 2 copies of the data. It is the equivalent of a read followed by a move. Perform until student record equals high values. Read student records. At end move high values to student record. End read. End perform. 9334567 FRANKCURTAINLM051. Student ID Student Name Course. S. Perform until student record equals high values. The high values here acts as a termination marker. The high values here acts as a termination marker, extremely rarely called a sentinel in software theory. If you have dealt with C programming and its dynamical memory reserving, you know you have to set up a termination marker, usually 0, to tell the algorithm that the last slot of the data container has been reached. The max value is used in COBOL probably because it is a rare value, as most developers design their value containers so that they never get even close to min or max values to eliminate the chances of buggy over or underflows that mess up the results. This simplified example shows how each row or record is loaded onto the input buffer. It does not show anything being done to those buffered records. Usually there are operations that process the buffered record before it is replaced with the next one. To write data to a file, move the data to the record buffer, declared in the FD entry, and then write the contents of record buffer to the file. Mnemonic name. Advance number. Advancing. Right. Lines. Line. After. Before. Record name from identifier. You do not always write things after a database read. Sometimes you just want to know the value. For example, your bank account balance. Open output student file. Move 9334567 frank curtain lm051 to student details. Write student details. Move 9383715 Thomas Healy lm068 to student details. Write student details. Close student file. Stop run. Oh. Program ID. Sec write. Author. Michael Coughlin. Environment Division. Input-Output section. File control. Select student assigned to students. Organization is line sequential. Data division. File section. FD student. 01 student details. 02 student ID pick 9, 7. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 date of birth. 03 YO birth pick 9, 2. 03 MO birth pick 9, 2. 03 DO birth pick 9, 2. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. Procedure division. Begin. Open output student. Display enter student details using template below. Enter no data to end. Perform get student details. Perform until student details equals spaces. Write student details. Perform get student details. End perform. Close student. Stop run. Get student details. Display CAIM ducks. Accept student details. I. This is not confirmed, though one case where you might not want to use line sequential is when you input data from several distributed databases as a byte stream. Byte streams do not necessarily have row markers or line feed symbols, and they might use other notations to separate the rows or records. (02) Course code pick X 4. 02 grant pick 9 4. 02 gender pick X. Procedure division. Begin. Open input student. Read student. At end move high values to student details. End read. Perform until student details equals high values. Display student ID space student name space course code. Read student. At end move high values to student details. End read. End perform. Close student. Stop run. Identification division. Program ID. Sec read. Author. Michael Coughlin. Environment division. Input-output section. File control. Select student assigned to students. Organization is line sequential. Data division. File section. FD student. 01 student details. 02 student ID pick 9, 7. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 date of birth. 03 YO birth pick 9, 2. 03 MO birth pick 9, 2. 03 DO birth pick 9, 2. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. Procedure division. Begin. Open input student. Read student. At end move high values to student details. End read. Perform until student details equals high values. Display student ID space student name space course code. Read student. At end move high values to student details. End read. End perform. Close student. Stop run. Perform is a loop structure that will be addressed in detail later. Accept student details. Procedure division. Begin. Open output student file. Display enter student details using template below. Press CR to end. Perform get student details. Perform until student details equals spaces. Write student details. Perform get student details. End perform. Close student file. Stop run. Get student details. Display nCAIM ducks. Accept student details. Enter student details using template below. Press CR to end. nCAIM ducks. 9456789 Coflams 5808112LM510598M. nCAIM ducks. 9367892RYANTG521210LM601222F. nCAIM ducks. 9368934 Wilson HR520323LM610786M. nCAIM ducks. Carriage return. X. $set source format free. Identification division. Program ID. Sec right. Author. Michael Coughlin. Environment division. Input-output section. File control. Select student file assigned to students. Organization is line sequential. Data division. File section. FD student file. 01 student details. 02 student ID pick 9, 7. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 date of birth. 03 YO birth pick 9, 2. 03 MO birth pick 9, 2. 03 DO birth pick 9, 2. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. SE code. Read student file. At end move high values to student details. End read. End perform. Close student file. Stop run. Procedure division. Begin. Open input student file. Read student file. At end move high values to student details. End read. Perform until student details equals high values. Display student ID space student name space course code. Read student file. At end move high values to student details. End read. End perform. Close student file. Stop run. $set source format free. Identification division. Program ID. Sec read. Author. Michael Coughlin. Environment division. Input-output section. File control. Select student file assigned to students. Organization is line sequential. Data division. File section. FD student file. 01 student details. 02 student ID pick 9, 7. 02 student name. 03 surname pick X, 8. 03 initials pick XX. 02 date of birth. 03 YO birth pick 9, 2. 03 MO birth pick 9, 2. 03 DO birth pick 9, 2. 02 course code pick X, 4. 02 grant pick 9, 4. 02 gender pick X. $. Two important characteristics of files are: data organization, method of access. Data organization refers to the way the records of the file are organized on the backing storage device. COBOL recognizes three main file organizations: sequential, records organized serially; relative, relative record number based organization; indexed, index-based organization. The method of access refers to the way in which records are accessed. A file with an organization of indexed or relative may still have its records accessed sequentially, but records in a file with an organization of sequential cannot be accessed directly. The simplest COBOL file organization is sequential. In a sequential file, the records are arranged serially, one after another, like cards in a dealing shoe. In a sequential file, the only way to access any particular record is to start at the first record and read all the succeeding records until you find the one you want or reach the end of the file. Sequential files may be ordered or unordered. These should be called serial files. The ordering of the records in a file has a significant impact on the way in which it is processed and the processing that can be done on it. In an ordered file, the records are sequenced on some field in the record. Chord F, record P, record W, transaction F. Program file, file sepr, cogtion.ram, procedure division, open extend UF, open input TF, read TF, move TFREC to UFREC, write UFREC, file section, procedure division, open extend UF, open input TF, read TF, move TFREC to UFREC, write UFREC. Chord B, record N, record A, record K, record G, record M, record H, record B, record N, record A, record K, record G, U. This process of adding new items to a data structure is often called appending. Append is the word. It is easy to add records to an unordered sequential file. But it is not really possible to delete records from an unordered sequential file. And it is not feasible to update records in an unordered sequential file. Records in a sequential file cannot be deleted or updated in situ. The only way to delete sequential file records is to create a new file, which does not contain them. The only way to update records in a sequential file is to create a new file which contains the updated records. Because both these operations rely on record matching, they do not work for unordered sequential files. We should have deleted record M. Too late. It's already been written to the new file. File SE. Shin. Proceedu. Rediv. Igen. Open in. Put TF. Open in. Put of. Open OU. TPUTNF. Read TF. Read of. If TFK. Why not? Equals OF key. Move of. R. E. C to NF rec. Write N. F rec. Read of. Else. Read TF. Read of. And if. TF. How can we recognize which record we want to delete? By its key field. File section. Procedure division. Open input TF. Open input of. Open output NF. Read TF. Read of. If TF key not equals OF key. Move OF rec to NF rec. Write NF rec. Read of. Else. Read TF. Read of. And if. Day Mental Copyright 2004 IBM Corporation. Record B. Record H. Record K. Record B. Record H. Record K. Transaction file. Record A. Record B. Record G. Record H. Record K. Record M. Record N. Record A. Record B. Record G. Record H. Record K. Record M. Record N. Ordered file. Program new file. File section. Procedure division. Open input TF. Open input of. Open output NF. Read TF. Read of. If TF key equals OF key. Update OF rec with TF rec. Move OF rec into NF rec. Write NF rec. Read TF. Read of. Else. Move OF rec to NF rec. Write NF rec. Read of. And if. Here, there are two inputs, 1. Transaction file and 2. Ordered file. The output is the new file. File SE. Shin. Proceedu. Re-div. IJN. Open in. Put TF. Open in. Put of. Open OU. TPUTNF. Read TF. Read of. If TFK. Y of. Key. Move TF. R. E. C to NF rec. Write N. F rec. Read TF. Else. Move of. R. E. C to NF rec. Write N. F rec. Read of. And if. A fun fact, nowadays this move instruction is called a value insertion or value copying. The move name probably comes from the CPU-level machine instructions where MV was used to copy values from a variable register to another. It is a much more efficient to process calculations that close to the CPU execution level. Such as perform are addressed. Now we are where the loop structures such as perform are addressed. Iteration is an important programming construct. We use iteration when we need to repeat the same instructions over and over again. Most programming languages have several iteration keywords, e.g. while, for, repeat, which facilitate the creation different types of iteration structure. COBOL only has one iteration construct, perform. But the perform has several variations. Each variation is equivalent to one of the iteration types available in other languages. This lecture concentrates on three of the perform formats. They perform varying, the COBOL equivalent of the for, will be introduced later. For loops are strange to laymen. They are pretty much for going through numbered sequences. Usually this means the numbered index slots of a table or an array or a database record. The use of numbering requires one to have a way of checking how many slots there are in total to avoid a crippling index out of bounds error. Usually this array count is provided as a parameter or it can be determined from the target object. For example, the size of the object is sometimes used in C when divided by the size of each slot. Most old languages start this numbering from 0, though newer ones are compatible with 1-based numbering or at least simulated because most people do not understand 0-based systems. The 0-based systems use the index as an offset from the start while the 1-based systems denote the order of the objects in sequence. You can get a 0-based numbering by deducting 1 from a specific item's order in the sequence. Back in business. A paragraph is a block of code to which we have given a name. A paragraph name is a programmer-defined name formed using the standard rules for programmer-defined names, AZ, 0 to 9. A paragraph name is always terminated with a full stop. Any number of statements and sentences may be included in a paragraph, and the last one, at least, must be terminated with a full stop. The scope of a paragraph is delimited by the occurrence of another paragraph name or the end of the program text. Process record. Display student record. Read student file. At end move high values to student record. End read. Produce output. Display here is a message. Note: the scope of process record is delimited by the occurrence the paragraph name. Produce output. It just means where one paragraph or a procedure starts, the previous one and its references end.
Hi, my name is David and I am held hostage. Nah, not really. David is the name of this Microsoft Voice Sound Pack, previously known as Microsoft SAM.
Get out, David, you are fired. Just kidding. This is the only type of perform that is not an iteration construct. It instructs the computer to transfer control to an out-of-line block of code. When the end of the block is reached, control reverts to the statement, not the sentence, immediately following the perform. 1 stproc and end proc are the names of paragraphs or sections. The perform through instructs the computer to treat the paragraphs or sections from 1 stproc to end proc as a single block of code. In other words, this is COBOL's take of a function call. Smiley face. One level down. Run of perform format 1. In top level. Starting to run program. Now in 1 level down. Now in 2 levels down. Back in 1 level down. Back in top level. In top level. Starting to run program. Now in 1 level down. Now in 2 levels down. Back in 1 level down. Back in top level. 1 level down. Display now in 1 level down. Perform 2 levels down. Display back in 1 level down. Procedure division. Top level. Display in top level. Starting to run program. Perform 1 level down. Display back in top level. Stop run. 2 levels down. Display now in 2 levels down. 1 level down. Display now in 1 level down. Perform 2 levels down. Display back in 1 level down. If and if. Procedure division. Begin. Perform sums else. Stop run. Sums else. Statements. Statements. If nor are found. Statements. Statements. If nor are found. Statements. 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 And if. And if. Looping lets you check each item for stuff like type automatically without having to process them manually. Add in automatic error resolving and you have pretty useful software in your hands. Procedure division. Begin. Perform sums ales through sums ales exit. Stop run. Sums ales. Statements. Statements. If error found, go to sums ales exit. And if. Statements. 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 If error found, go to sums ales exit. And if. Statements. Sums ales exit. Exit. Procedure division. Begin. Display name. Statements. Perform display name 4 times. Statements. Stop run. Display Tom Ryan. Identification division. Program ID. Perform example 2. Author. Michael Coughlin. Data division. Working storage section. 01 num of times pick 9 value 5. Procedure division. Begin. Display starting to run program. Perform 3 times. Display this is an inline perform. End perform. Display finished inline perform. Perform out of line eg number of times. Display back and begin. About to stop. Stop run. Out of line eg. Display this is an out of line perform. Starting to run program. This is an inline perform. This is an inline perform. This is an inline perform. Finished inline perform. This is an out of line 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 perform. Back and begin. About to stop. The repeating of the same operation multiple times is typical when dealing with inputs and outputs. For example, if you want to process 5 records at a time, you might use the times keyword. This format is used where the while or repeat constructs are used in other languages. If the with test before phrase is used, the perform behaves like a while loop and the condition is tested before the loop body is entered. If the with test after phrase is used, the perform behaves like a repeat loop and the condition is tested after the loop body is entered. The with test before phrase is the default and so is rarely explicitly stated. This repeat term is somewhat rare in modern languages. They use the do, while structure instead. It executes the operation one time before checking for the iteration conditions. I guess repeat sounds more distinct from while. In general terms, the while loop is an ideal construct for processing sequences of data items whose length is not predefined. Such sequences of values are often called streams. Because the length of the stream is unknown, we have to be careful how we manage the detection of the end of the stream. A useful way for solving this problem uses a strategy known as read ahead. Read ahead checks if the next item is a terminator before continuing. If it is the terminator such as high values, it will end the processing loop. With the read ahead strategy, we always try to stay one data item ahead of the processing. The general format of the read ahead algorithm is as follows. Attempt to read first data item, while not end of stream. Process data item. Attempt to read next data item, and while. Use this to process any stream of data. Algorithm template. Read student records. At end, move high values to student record. End, read. Perform until student record equals high values. Display student record. Read student records. At end, move high values to student record. End, read. End, perform. This is an example of an algorithm which is capable of processing any sequential file, ordered or unordered. The reason for why the terminator item is added to student records is that while the file already has a distinct end of file point, the student's records file does not, because you just created it, and that is why you have to add it to it. Algorithm template. Read student records. At end, move high values to student record. End, read. Perform until student record equals high values. Display student record. Read student records. At end, move high values to student record. End, read. End, perform. This is an example of an algorithm which is capable of processing any sequential file, ordered or unordered. Procedure division. Begin. Open input student file. Read student file. At end move high values to student details. End read. Perform until student details equals high values. Display student ID space student name space course code. Read student file. At end move high values to student details. End read. End perform. Close student file. Stop run. That is enough about loops. Most COBOL arithmetic verbs conform to the template above. For example, add takings to cache total. Add males to females giving total students. Subtract tax from gross pay. Subtract tax from gross pay giving net pay. Divide total by members giving member average. Divide members into total giving member average. Multiply 10 by magnitude. Multiply members by subs giving total subs. The exceptions are the compute and the divide with remainder. Receiving field actual result truncated result rounded result. Pick 9, 3, V9. 123.25. Pick 9, 3. 123.25. 123.2 123.3. 123 U. The rounded option takes effect when, after decimal point alignment, the result calculated must be truncated on the right hand side. U. The option adds 1 to the receiving item when the leftmost truncated digit has an absolute value of 5 or greater. A size error condition exists when, after decimal point alignment, the result is truncated on either the left or the right hand side. U. If an arithmetic statement has a rounded phrase, then a size error only occurs if there is truncation on the left hand side, most significant. Receiving field actual result size error. Pick 9, 3, V9. 245.96. Pick 9, 3, V9. 1245.9. Pick 9, 3. 124. Pick 9, 3. 1246. Pick 9, 3, V9 not rounded 124.45. Pick 9, 3, V9 rounded 124.45. Pick 9, 3, V9 rounded 3124.45. Yes. Yes. No. yes, yes, no, yes. A size error condition exists when, after decimal point alignment, the result is truncated on either the left or the right hand side. If an arithmetic statement has a rounded phrase, then a size error only occurs if there is truncation on the left hand side, most significant digits. Students. Before 1500 0625 1234. After. Add cash to total. Before 3 1000. After. Add cash, 20 to total, wage. Before 3 1100. After. Add cash, total giving result. Before 3 1000 0015. After. Add males to females giving total students. Before 1500 0625 1234. After 1500 0625 2125. Subtract tax from gross pay, total. Before 120 4000 9120. After. Subtract tax, 80 from total. Before 100 480. After. Subtract tax from gross pay giving net pay. Before 750 10000012. After. 12. ROR display total subs too small. And multiply. Subs members total subs. Before 15.50 100 0123.45. After. Multiply 10 by magnitude, size. Before 355 125. After. Divide total by members giving average rounded. Before 9234.55 100 1234.56. After. M. Ocean remainder remain. Before 209 424. After. Divide 201 by 10 giving quotient remainder remain. Before 209 424. After. U. 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 E. 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 Y. U. I. 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 Y. U. I. 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 Y. U. I. 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 U. 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 E. 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 Y. U. I. 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 Y. U. I. 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 Y. U. I. 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 Statement B lock end, divide. Not on size error. On size error. Divide by giving identifier rounded remainder identifier. Statement B lock end, divide. Not on size error. On size error. Divide into giving identifier rounded remainder identifier. Literal. Identifier. Literal. Identifier. Literal. Identifier. Literal. Identifier. Arithmetic and edited pictures. The divide exception. 02001. After. Compute Irish price equals sterling price slash rate asterisk 100. Before 1000.50 156.2587. After 179.59 156.2587. Precedence rules. 1. Equals power nn. 2. Asterisk equals multiply x. Slash equals divide divided by. 3. Plus equals add plus. Equals subtract. Precedence rules. 1. Equals power nn. 2. Asterisk equals multiply x. Slash equals divide divided by. 3. Plus equals add plus. Equals subtract. U. 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 E. 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 Y. U. I. 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 Statement block and compute. Not on size error. On size error. C. Edited pictures are picture clauses which format data intended for output to screen or printer. To enable the data items to be formatted in a particular style, COBOL provides additional picture symbols supplementing the basic 9, X, A, V and S symbols. The additional symbols are referred to as edit symbols and picture clauses which include edit symbols are called edited pictures. The term edit is used because the edit symbols have the effect of changing, or editing, the data inserted into the edited item. Edited items cannot be used as operands in a computation, but they may be used as the result or destination of a computation, i.e. to the right of the word. Giving. COBOL provides two basic types of editing. OE insertion editing, which modifies a value by including additional items. Suppression and replacement editing, which suppresses and replaces leading zeros. Each type has subcategories. L insertion editing. Registered trademark simple insertion. Registered trademark special insertion. Registered trademark fixed insertion. Registered trademark floating insertion. L suppression and replacement. Registered trademark zero suppression and replacement with spaces. Registered trademark zero suppression and replacement with asterisks. Al insertion. Plus, CRDB $fixed insertion. Plus, S floating insertion. Z asterisk suppression and replacement. B0 / simple insertion. Special insertion. Plus, CRDB $fixed insertion. Plus, S floating insertion. Z asterisk suppression and replacement. E. Pick 9, 6, 002178 pick. Pick 9, 6, 120,183 pick 99B99B99. Pick 9, 6, 120,183 pick 99/99/99. Pick 9, 6, 001245 pick 990,099. Sending receiving. Picture data picture result. Pick 999,999 123,456 pick 999,999. Pick 9, 6, 000078 pick 9, 3, 9, 3. Pick 9, 6, 000078 pick ZZZZZZ. Pick 9, 6, 000178 pick. Pick 9, 6, 002178 pick. Pick 9, 6, 120,183 pick 99B99B99. Pick 9, 6, 120,183 pick 99/99/99. Pick 9, 6, 001245 pick 990,099. 123,456. 000,078. 78. 178. 2,178. 12,0183. December 1st, 83. 120,045. 999.9. Pick 999V99 51,234 pick 99.99. Pick 999 456 pick 999.99. Sending receiving. Picture data picture result. Pick 999V99 12,345 pick 999.99. Pick 999V99 pick 999.9. Pick 999V99 51,234 pick 99.99. Pick 999 456 pick 999.99. 123.45. 023.4. 12.34. 456.00. 99-123 pick -999. Pick S999-123 pick 999. Pick S999 plus 123 pick -999. Pick S9, 5, plus 12,345 pick plus 9, 5. Pick S9, 3, minus 123 pick plus 9, 3. Pick S9, 3, minus 123 pick 999 plus. Sending receiving. Picture data picture result. Pick S999 minus 123 pick minus 999. Pick S999 minus 123 pick 999. Pick S999 plus 123 pick minus 999. Pick S9, 5, plus 12,345 pick plus 9, 5. Pick S9, 3, minus 123 pick plus 9, 3. Pick S9, 3, minus 123 pick 999 plus. Minus 123. 123. 123. Plus 12,345. Minus 123. 123. Although COBOL data items are not typed, they do fall into some broad categories, or classes, such as numeric, or alphanumeric, etc. A class condition determines whether the value of data item is a member of one of these classes. I, 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 Y, U, I, 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 I. User-defined class name. Alphabetic, upper. Alphabetic, lower. Alphabetic. Numeric. I. The sign condition determines whether or not the value of an arithmetic expression is less than, greater than, or equal to 0. Sign conditions are just another way of writing some of the relational conditions. Programs often require conditions which are more complex than single-value testing or determining a data class. Like all other programming languages, COBOL allows simple conditions to be combined using OR and AND to form composite conditions. Like other conditions, a complex condition evaluates to true or false. A complex condition is an expression which is evaluated from left to right unless the order of evaluation is changed by the precedence rules or bracketing. The OR thing is pretty much is affordable or good, and the N one is something like if it is dark and cold. It sounds much more difficult than it is. We all do OR and A.N.D algorithmic choices every day when choosing what and when to do. Just like arithmetic expressions. Precedence rules. Precedence rules. 1. Not equals. 2. N equals asterisk or slash. 3. Or equals plus or. Just like arithmetic expressions, complex conditions are evaluated using precedence rules, and the order of evaluation may be changed by bracketing. Examples. If row 0, n, row var c, or var c equals vard, or var a not equals var f. Display done. And if when a data item is involved in a relation condition with each of a number of other items, it can be tedious to have to repeat the data item for each condition. For example, if total amt 10,000 and total amt var b and vara var c and vara vard display vara is the greatest, and if. In these situations, COBOL provides an abbreviation mechanism called implied subjects. The statements above may be rewritten using implied subjects as: if total amt 10,000 and var b and var c and vard display vara is the greatest, and if. Implied subjects total amt grade equals vara. Implied subjects total amt grade equals vara. There is a similar thing with the consequences too in most languages. C has the question mark notation. That way you do not have to write the whole if-else-if boilerplate every time and can focus on their content. Implied suspects is not a term most programmers recognize. A lot of the old COBOL vernacular is like that. They are better known with newer terms. If vara var c, then. If var g equals 14, then. Display first. Else. Display second. And if. Else. Display third. And if. If vara var c, then. If var g equals 14, then. Display first. Else. Display second. And if. Else. Display third. And if. Vara var b var c var g display. 3 4 15 14. 3 4 15 15. 3 4 3 14. 13 4 15 14. Vara var b var c var g display. 3 4 15 14. 3 4 15 15. 3 4 3 14. 13 4 15 14. T first. TTF second, TF third, FT third. There is a practical rule in programming that only 2 nested levels are allowed. Anything beyond that should use a function call that handles its own deeper nesting there. Anything more than that is a readability concern. Wherever a condition can occur, such as in an if statement or an evaluate or a perform until, a condition name, level 88, may be used. A condition name is essentially a Boolean variable which is either true or false. Example: if student record equals high values then action. The statement above may be replaced by the one below. The condition name end of student file may be used instead of the condition student record equals high values. If end of student file then action. Ed condition name. Remember, the record field hierarchies are limited to the range between 00 and 49. 66, 77, and 88 have special uses. 88 seems to be a constant called condition name. Condition names are defined in the data division using the special level number 88. They are always associated with a data item and are defined immediately after the definition of the data item. A condition name takes the value true or false depending on the value in its associated data item. A condition name may be associated with any data item whether it is a group or an elementary item. The value clause is used to identify the values which make the condition name true. Value 1 through 4. 01 City Code Pick 9 Value 5. 88 Dublin Value 1. 88 Limerick Value 2. 88 Cork Value 3. 88 Galway Value 4. 88 Sligo Value 5. 88 Waterford Value 6. 88 University City Value 1 through 4. If Limerick, display hey, we're home. And if University City, perform calc rent surcharge. And if Limerick, display hey, we're home. And if University City, perform calc rent surcharge. And if Dublin false, Limerick false, Cork false, Galway false, Sligo true, Waterford false, University City false. City Code 5. Conditions E. Zero 1 Input char pick X. 88 Vowel value A. E. I. O. U. 88 Consonant value B through D. F. G. H. J through N. P through T. V through Z. 88 Digit value 0 through 9. 88 Lowercase value A through Z. 88 Valid char value A through Z. 0 through 9. If valid char, display input OK. And if lowercase, display not uppercase. And if vowel, display vowel entered. And if valid char, display input OK. And if lowercase, display not uppercase. And if vowel, display vowel entered. And if vowel true, consonant false, digit false, lowercase false, valid char true. This condition name 88 thing seems like something that could be called Boolean OR set. (01) end of file flag pick 9 value 0. 88 end of file value 1. 01 end of file flag pick 9 value 0. 88 end of file value 1. Read in file. At end move 1 to end of file flag. End read. Perform until end of file. Statements. Read in file. At end move 1 to end of file flag. End read. End perform. Read in file. At end set end of file to true. End read. Perform until end of file. Statements. Read in file. At end set end of file to true. End read. End perform. Set not end of file to true. So this set thing seems to be used to set flag values for some reason. It is about recording the program state. Evaluate true position. When L arrow 2 through 10 perform move left. When R arrow 1 through 9 perform move right. When L arrow 1 move 10 to position. When R arrow 10 move 1 to position. When delete key 1 perform can't delete when character. Any perform insert char when other perform display error message. And evaluate. The program to calculate the total taxes paid for the country is easy to write. But what do we do if we want to calculate the taxes paid in each county? Procedure division. Begin. Open input tax file. Read tax file. At end set end of tax file to true. And read. Perform until end of tax file. Add tax paid to tax total. Read tax file. At end set end of tax file to true. And read. And perform. Display total taxes are, tax total. Close tax file. Stop run. Procedure division. Begin. Open input tax file. Read tax file. At end set end of tax file to true. And read. Perform some county taxes until end of tax file. Display county 1 total is, county 1 tax total. 24 statements. Display county 26 total is, county 26 tax total. Close tax file. Stop run. Some county taxes. If county number equals 1, add tax paid to county 1 tax total. And if 24 statements. If county number equals 26, add tax paid to county 26 tax total. And if read tax file. At end set end of tax file to true. And read. This is a warning example. You should use different records or tables to store the different values instead of manually creating variable names for them. You cannot do this in systems with millions of variable values. Ten. 1, 2, 3, 4, 5, 6. Move 10 to county tax, 5. Add tax paid to county tax, county number. Add tax paid to county tax, county number plus 2. A table is a contiguous sequence of memory locations, called elements, which all have the same name, and are uniquely identified by that name and by their position in the sequence. A. The position is often denoted by a zero-based index offset of non-negative integers. The more common name for a table element is table item. That county num plus 2 is because the numbers in the sequence are 2 digits wide. So there will be a new value every 2 characters of 2 characters length. Or not. It is unclear why there are empty slots in the table. Terminators perhaps. Okay, so it is still manually adding values into those table slots even though it could just perform loop it through. COBOL seems to be unusual in its table or array notation. Usually the languages use brackets for table indices and parentheses for function parameter lists. COBOL uses perform instead for functions, so it is different. Perform varying, that seems to be COBOL's for loop. Perform varying IDX from 1 by 1. Until county, IDX, equals county name. And perform. Add tax paid to county tax, IDX. IDX is short for index. Most people use the variable name I for it in C languages. 01 tax totals. 02 county tax details occurs 26 times. 03 county tax pick 9, 10, V99. 03 payer count pick 9, 7. E.g. move 25 to payer count, 2. Move 67 to county tax, 5. Move zeros to county tax details, 3. Why we use COBOL. The problem of program maintenance. How COBOL programs should be written. Efficiency vs clarity. Producing a good design. Introduction to design notations. Guidelines for writing COBOL programs. COBOL is an acronym standing for Common Business Oriented Language. COBOL programs are, mostly, written for the vertical market. COBOL programs tend to be long-lived. Because of this longevity, ease of program maintenance is an important consideration. Why is program maintenance important? Maintenance costs are only as low as this because many systems become so unmaintainable early in their lives that they have to be scrapped. Boom. Program maintenance is an umbrella term that covers 1. Changing the program to fix bugs that appear in the system. 2. Changing the program to reflect changes in the environment. 3. Changing the program to reflect changes in the user's perception of the requirements. 4. Changing the program to include extensions to the user requirements, i.e., new requirements. What do these all have in common? Changing the program. You should write your programs with the expectation that they will have to be changed. This means that you should registered trademark write programs that are easy to read. Registered trademark write programs that are easy to understand. Registered trademark write programs that are easy to change. You should write your programs as you would like them written if you had to maintain them. Many programmers are overly concerned about making their programs as efficient as possible, in terms of the speed of execution or the amount of memory used. But the proper concern of a programmer, and particularly a COBOL programmer, is not this kind of efficiency, it is clarity. As a rule, 70% of the work of the program will be done in 10% of the code. It is therefore a pointless exercise to try to optimize the whole program, especially if this has to be done at the expense of clarity. Write your program as clearly as possible and then, if it's too slow, identify the 10% of the code where the work is being done and optimize it. We shouldn't design our programs when we want to create programs that do not work. We shouldn't design when we want to produce programs that do not solve the problem specified. When we want to create programs that get the wrong inputs, or perform the wrong transformations on them, or produce the wrong outputs, then we shouldn't bother to design our programs. But if we want to create programs that work, we cannot avoid design. The only question is, will it be a good design or a bad design? The first step to producing a good design is to design consciously. Subconscious design means that design is done while constructing the program. This never leads to good results. Conscious design starts by separating the design task from the task of program construction. Design consists of devising a solution to the problem specified. Construction consists of taking the design and encoding the solution using a particular programming language. Separating program design from program construction makes both tasks easier. Designing before construction allows us to plan our solution to the problem, instead of stumbling from one incorrect solution to another. Good program structure results from planning and design. It is unlikely to result from ad hoc tinkering. Designing helps us to get an overview of the problem and to think about the solution without getting bogged down by the details of construction. It helps us to iron out problems with the specification and to discover any bugs in our solution before we commit it to code. See next slide. Design allows us to develop portable solutions. A number of notations have been suggested to assist the programmer with the task of program design. Some notations are textual and others graphical. Some notations can actually assist in the design process, while others merely articulate the design. Ugh, so ugly. The more you look at it, the more helpful and clear it looks like. The complex part is how it portrays different operations for different record types, payment and receipt. For each transaction record, do the following. If the record is a receipt, then add 1 to the receipts count. Add the amount to the balance. Otherwise, add 1 to the payments count. Subtract the amount from the balance. And div. Add 1 to the record count. Write the balance to the customer file. When the file has been processed, output the receipts count, the payments count, and the record count. Absolutely terrible. This creates more questions than answers. Any existing process could be improved. Thank you very much. Thanks for coming to my Codex talk, smiley face. See you next time.